We're going to have ONeal presenting today on Raspberry Pi. Just so you know, next month it will be a week later than normal. We'll be on the third Wednesday, the 15th, at the normal time. But we'll be having Brandon Johnson. Let me check. Brandon Johnson will be presenting on open source virtualization and management. So that's next month. It will be on the 15th. So whenever AJ's ready, looks like he's about ready. Turn it over to me.
So if I figure out to go faster, right? Cool. Okay, so I'm going to talk a little bit about embedded in general. These are just my slides from Utah, so if you were there, this will be boring. If you weren't, then you'll be happy. Okay. So brief introduction. I'm a longtime Linux fan, short-time embedded fan. I work at a radar company called SpotRF. We have a tracking system that we do. And the hardware guys there are really smart, and they kind of turned me on to some of this cool miniature technology. So does everybody know what ARM is? Or who doesn't know what ARM is? Do we have some hands in here? Everybody's got a good grasp on that? So, okay.
I mean, it just implies embedded systems, or I don't know exactly what devices that would be.
So there's a couple different architectures that are reduced instruction set computers, RISC, and then a lot of times they're paired with DSP. So your ISA is like x86 or x64. Anybody feel free to correct me if I'm wrong on any of this stuff, because I don't pretend to be an expert. But ARM is a particular type of ISA that's a RISC ISA, which means that it's lower power, it has fewer instructions, it just doesn't do as much. It's not as powerful. And it's licensed by a company called ARM Holdings. And often ARMs are paired with DSPs so that you can have really low power devices. That the ARM handles all the business logic, and then the DSP handles things like your video encoding, your cell phone call, etc. So just a brief overview, x86 is Intel. That's what you've always had. x64 is what AMD started, and now has been taken over pretty much by Intel. But Intel licenses their x64 architecture from AMD. PowerPC is what's in all your game systems. It's also in the Western Digital MyBook. So if you've ever used one of those Ethernet connected hard drives, some of those are PowerPC. MIPS is like maybe a step down from ARM, and that's basically what powers all of your routers, some of the older cell phones. I think all the newer cell phones run ARM, but some of the older ones have MIPS. And then yeah, your ARM plus DSP is basically all your cool stuff that is really small or really compact. So your new TVs, your Game Boy type devices from whatever company you like. And the reason for ARM is because it's small and low powered. So this right here can actually run off of, well, it runs off of USB power. That's how this one is powered. Where's my, did you happen to grab the, oh, this is in the box. Anyway, so this just takes any Android phone that you have has got a micro USB connector, and the Raspberry Pi here. I don't want to disconnect this, but I kind of do. I'll leave it. You just plug it in right there, and you've got your computer powered off of a 5-volt power supply that you can then plug into this Mac over here, and then the blinky lights turn on. It's powered. That's how simple it is. So that's a major advantage of it. And then in terms of if you want to create some sort of hobbyist device that you want to have a controller for, you're not hardcore enough to go with Arduino or some of that other hardcore stuff, you get a familiar Linux system, but in a very small space that you can build a Lego case out of. Has anybody seen the Lego case online? Somebody mentioned it. But, yeah, so it's pretty neat. But there's some complications with embedded development, and that includes hardware, software, Toolchain are your main components. So hardware, there's lots of different platforms you can choose from. So if you are on the Raspberry Pi waiting list and you're not going to get it for like the next year or whatever, some other ones that are interesting that are out are Shiva Plug's been around a long time, BeagleBoard's been around a long time, PandaBoard is a successor to BeagleBoard. Gumsticks is like super small, a little tiny, like literally a stick of gum. That's how small the thing is. And then it comes with expansion boards that are like this size, and you snap the little gum stick onto the expansion board, and you can get them, like some of them are almost this size, and you can get screens for it, touch screens, all that. It's, they're I think the largest commercial distributor. These other ones are like kind of open source or educational or whatever. There's one called Snowball. And there's another one that's got like the NVIDIA Tegra chip on it. I can't remember what it's called right now. But so if you're looking into stuff, the thing that's probably most cost effective is the PandaBoard, because it's $174 for the older revision, $182 for the newer revision. And it's got Gig of RAM, dual core, 1 gigahertz processor, whereas the Raspberry Pi is much less powerful. It's got a 600 megahertz processor. I think actually 700. Anyway, you can overclock it if you want it, but then you have to put like a heat sink or something on there. And it's only got 256 megs of RAM. But for 35 bucks, I mean, you can run just about any Linux. Bunch of junk you want on there. So then the OS stack. Fedora and Arch are also getting into the market with ARM, but Ubuntu is kind of the pioneer. They've been doing stuff on ARM for a long time, and they have a spin-off called Monaro. And then Gentoo has a spin-off, which probably has existed longer than Ubuntu's spin-off, actually, called Open Embedded. And it's been rewritten, so if you talk to somebody about it, they'll probably smack you in the face if you say it's Gentoo, but it's based off of Gentoo, and it's just as terrible to use. So if you're into sadism, masking, whatever that is, you'll like that one. So the Toolchain is different from your operating system. Toolchain means like your compiler set. So has anybody done cross-compiling before? So a few of you. Those of you that haven't, it's like headache. So you want to have a good toolchain, because if you don't have a good toolchain, then weird things happen. Like perfectly valid C code compiles to perfectly not valid assembly code, and then when you run your program, it runs for a little bit, and then it throws an illegal exception because you reach some part in the program where it either doesn't have the right instruction in the assembly level, or it just is compiling bad, and it, I don't know, isn't accounting for Indianness or something strange like that, and then you end up in some weird memory space, and you seg fault, or you seg pipe, or you seg any of those seg things. They're all bad, and so cross-compiling really sucks, because it means, I mean, does anybody think that compiling is kind of annoying? Just like you're on your x86 box, like, yeah, this is easy, but it's still hard. It's like really, really easy in comparison, because cross-compiling means you have to set all these environment flags and stuff. So there's a couple different toolkits. Monaro seems to be a really good one, because there's a lot of companies that are interested in it. Code Sorcery has been around a really long time, and all of the, like before you had cool things like this, like BeagleBoard and PandaBoard that were making a name for it. Code Sorcery was the toolchain that, like the one-off boards that were being created on, per order basis. we're using. And then open embedded is the one that I like the least out of things I've played with. And then you actually get to your development. The cool thing is that much like how you can only interface with this with HDMI, and same thing here, or you can use the composite out actually, but there's no VGA on here. They don't deal a lot with old technologies. Java is really hard to get running on ARM. But C of course will work. But then your higher level languages, Python, that works great. Golang and Node.js, Lua actually has got some good ARM support from what I hear. But some of these newer languages that are kind of rising in popularity, they're jumping on the ARM bus too because it's cool right now. What's different about it than your basic x86 system, there's no bootloader, or there is a bootloader, but it's not like Grub. It's the CPU knows to look to a certain address, just like your bootloader, but it's going to be on your SD card or in NAND that's built in on the chip package. So these chip packages are a stack of the processor, the memory, and the NAND are like all together in one little item. So on here, I believe that's this little chip right here is the one. I believe that's the 1 gigabyte of RAM, the dual core gigahertz processor, and the NAND.
So there's no massive heat sink on this, does it not get hot?
No, like you can just hold your finger on it the whole time. You can overclock them, and then you could just steal a heat sink, the kind of heat sink you would use on like a VIA chipset on your motherboard. If you got an old motherboard, you can just rip one of those off and stick it on here. It's about the right size if you've got a small one for like the South Bridge or something. But yeah, you don't have to worry about the heat sink most of the time. But anyway, the boot process is a little bit different. Obviously, you're not just like sticking in your CD drive and then booting off of a CD to install the operating system. You get an image that's been compiled, perhaps cross-compiled, well, at some points cross-compiled and perhaps native compiled parts of it, and run in QEMU. Has anybody ever used QEMU before? How about VirtualBox? Yeah, okay, so VirtualBox is a successor, as I understand it, of QEMU, and QEMU does multiple architectures, not just x86, but ARM and MIPS, and that's how old school people do the development there. But we don't have to deal with that because we get to go to the website and download these nice packages that have that stuff on there for us. Come back to me, And then the way you interface with this is not through, there's no PCI slot on here, so you actually get to get your hands dirty, like what you see here. You can buy kits that actually put a board that has easy to connect to headers that you stack on top of this, or you can just use these breadboard wirings to attach onto pins. But when you want to interact with this thing, like say I want to put a GPS on this, then what I'd basically be doing is buy a GPS chip off of eBay and connecting these wires to the GPS chip and then connecting them to the right pins on here. And I'm going to show you some resources for that because they're a little bit hard to find with the Raspberry Pi. The documentation in the community isn't quite cohesive yet. So I'll give you a quick start on that. Compile times are really, really slow if you need to compile something, which likely you will, because unless you're just sticking with Python for the development you're doing, if you're going to use Go or one of these other languages that's not quite so popular but has some target towards ARM, you'll have to end up compiling it, and it'll take an hour. It's a slow process. But the payoff is that it's fun because you put this in your pockets, you have your phone USB cable, you can whip it out and brag to people, you can attach it to a hard drive that's bigger than it is and have a little media server, which is, that's the plan I have for this, the plan that I originally had for this. I have too much money to buy these devices, but not enough time to use them. But I'm actually working on a media server, and that's the thing that's like really piqued my interest in ARM. I want something you can just set aside, like your TV, buy your TV, like the Apple TV or Google TV devices, but then have a much more intuitive media management interface with it. And then it goes down again. Maybe I should have put it on no sleep. Let's see it come back. Can I get that option now? Let me just turn this to not sleep real quick. Never. Okay. Never. Great. Okay, I'll show you that now. Okay, so what I want to do now is just kind of walk you through the process of how to get set up with the Raspberry Pi. And the Panda board is pretty similar, and these other boards, they all kind of follow the same suit. So once you've gone through the process once, you're like about 10,000 steps ahead on doing it a second time on any other platform. But first off, any questions so far? Comments? All right, cool. So let me close this. Don't know why the default isn't to just make it maximize to the size of the screen. All right. So, has everybody visited the Raspberry Pi website before?
Yes.
Excellent. So you'll find that they've got this download section here, and it kind of gives a really high-level overview of what to do with the download, but it doesn't give you quite enough information, so I'm just going to walk through that process. And make sure that I've unmounted my drives. Okay, come back. Zoom, enhance. Reject all. Oh, oops, didn't like that. Oh well, it'll be over. So here I've got a micro SD card inside of a regular SD card slot, and there's a really cool project on Kickstarter that they're aiming it towards Macs, so the price point's going to be like $35, but basically they take one of these and make it so you insert it sideways instead, so that instead of having this huge bulk come out of devices like this and your MacBook, that you only have the absolute minimum bulk necessary. Because that is kind of annoying that this thing sticks out so far. I'm kind of sad that they decided to go with SD, but I'm guessing it's to save cost. The thing is only $35. Anyway, so I've got the SD card in there, and get a new terminal open. Maybe loosen this up a bit. So right now, I would recommend using the Arch distribution. Ubuntu doesn't have a distribution for Raspberry Pi because their focus is on the newer chipsets, and this is an older one, hence being much cheaper. But Debian has a release. Fedora is supposed to have a release for this. I don't know why there's not a link on the website, but I've tried the Debian and the Arch. They both have quirks with them when you first get them set up, but the Arch one is a heck of a lot faster. It's a very, very minimal system. So here's the direct download. Of course, I recommend you use a torrent. I couldn't figure out how to get that to work from the command line, unfortunately. But so you go, you get your download. It downloads. I've got it in my downloads folder here. For some reason they packaged it as a zip, so we've got that to deal with. You can see I've been playing around with Arch a little bit on x86 as well. So you unpackage the zip file, and they come out with new versions every couple months, but they don't necessarily update the website right away. Boom, 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 and plates. Just in case you didn't know about the unzip command, because you're all Linux people and you probably don't use unzip because it's not tar. Okay, cool. So that took forever. And was anybody at the Z-Shell presentation at Utah's? So I didn't actually go, but I had a friend who went and he converted me to it. That's what I'm using as my shell. So if you see like cool auto-completion stuff just happening.
It's on YouTube.
Yes, it is. Oh, whoops. There we go. So I go into this directory that was extracted, and then I don't know if they put this in the quick start guide or not, but I will tell you how it's done. Yeah, they kind of really gloss over things here. I've got a blog post about this. I don't think I actually published it yet, but I will, and I'll send a link out on the list so you can see what these commands are. But you use DD. Anybody used DD before? Okay, that's good. So you got some familiarity there. All you do is put your input file as the .img, and then you put your output file. Well, actually first, because most of you probably run desktops, so you probably get your disks auto-mounted. I'm using, if any of you have Mac and you want to know how to do ext2, there's a OS X fuse, kind of like the fuse in Linux. That's what I'm using to have these auto-mounted. But now I have to unmount them, so you would use unmount. I have to use diskutil unmount. And you would use SDA1, or, well, not SDA, like SDC or something. And I have to use disk1 S1. And my password doesn't work anymore. Okay. I just suck at typing it. So it's important to unmount and not to eject, because if you eject, then your card goes away and the power turns off.
Do you want a chair? Do you want a chair?
Oh, that'd be great, actually.
Thanks.
So now if I do mount again, I see that it's not mounted, and it's important to notice what the device name is, because of course you don't want to DD over your hard drive, because that would make you very sad.
Which disk? What did you unmount? Is it the device itself or your own laptop?
I unmounted the SD card that I have. So I've just got my SD card plugged into my SD card reader here. But yeah, if you use the GUI tools to unmount it, most of the time it powers it off, and so then you have to take it out and stick it back in and then do it with the command line. So all right, now it's unmounted, and now I could do input file is this image, output file is dev on Mac, it's going to be rdesk1, byte size is, you would do capital M, I have to do lowercase m, but you get the picture, and then for the interest of time, because this takes about 15 minutes, this card is already prepared. What will happen a lot of times as soon as it finishes writing it, the kernel will then reread the partition table and then auto-mount it again. So, you know, you Ubuntu users and Mac users have to then again unmount it, but this time you can go to turn it off. I don't have to do that right now. And then,
So one question, I know with like USB drives and stuff, at least with on the x86 and 64 architecture, you need to use, you have to have your drive has to support being able to boot off of it. Are there any limitations? Because I know you said it doesn't use BIOS or anything. Are there any limitations to which you have to get a certain kind of drive? SD card?
No, although I've had trouble with some SD cards before, and what that trouble has been is, say you buy from Transcend. Well, Transcend buys their chips that go on their PCBs from several different manufacturers. Whoever bids cheapest that day, that's the one they buy from. And there's, I think it's either Kingston or King Max does the same thing, but SanDisk and what's the other one? SanDisk is a good card to go with because you probably have the fewest problems with them. Transcend, you'll probably it's one of either Kingston or King Max is good and the other one's bad. So if you get confused, the SanDisks work the best. The other ones, sometimes you have to write out the file twice, or you have to like edit the partition table, and then all you gotta do is like open it up and then write it out, and then it starts working. But I will show you. Okay, good mounted. So it'll always have a FAT32 partition, no matter which operating system you're using, that has the bootloader on it. And the special thing about the bootloader is it has to be the first file written. So if you're using something that's a little bit more custom than the Pi, where you actually have to go through a little bit of a build process, or you have to choose a bootloader, or a bootloader that matches the kernel or whatever, they'll have you copy the files over to the boot partition in a very specific order. This file happens first, and then these two, or these three. And so this one, I think this is the bootloader here, one of these maybe, or no, it's probably bootcode.bin. And then they have a text file usually that serves the same purpose as your grub configuration will. And sometimes you have to compile the text file, which the one loader I've used is called MLO, and with that boot configuration, all it does is take a checksum of the file and stick it at the beginning, so that if you wanted to edit it without having to install additional tools or doing something complicated, you can't, because if you edit the file, it voids the checksum and then it won't boot. But this one, the bootloader they've got here just uses a plain text file with comments like you're used to, and there's nothing too fancy about it. I don't know what all the rest of these files do. So they kind of violate the GPL a little bit with some of these systems, because the vendors don't necessarily release their code, but they copy it over there anyway, and then sometimes they have to include things like license.broadcom, where it tells you that this code is actually proprietary or something or other like that. So it seems like it's not as GPL as you would hope it would be, some of the things. And then here, this is just normal partition, what you're used to. So I will go ahead and unmount these graphically, which will turn the power off. Nice, alrighty. So now I just plug this in. Give it some power. Well, I guess first I want to connect it to the projector. So this one's nice in that they've already configured the HDMI output for you. Sometimes maybe the operating system you're using will have a misconfiguration, like when the Arch release that I used a few months ago wasn't actually configured properly, and so I had to edit that config.txt file that I showed. And it was a simple one-line change. They had it set to like whatever specific monitor the developer was using at the time that he created the image, which happens to be not 99% of monitors. So you delete the file and then it just starts working. And can I change the source on this? Oh no, I don't need to change the source, do I? Because I just switched the cable. But and I probably need to plug this in first. These devices aren't necessarily as plug and play as what you're used to. Sometimes you have to plug in the USB before you get started. I don't know if that's going to be the case.
Discovery time.
And usually this is really fast. The Arch one boots really quickly, but because it's not finding DHCP, it's kind of upset. I'm not really sure what to do about that other than wait. But it's got a cute little Pi logo instead of Tux. don't know. Maybe have mixed feelings about that.
We could hack it in so that they're both there.
You could. Well, while that's doing that, I'm going to switch over, and there were some links that I wanted to pull up about this, things that are a little bit more difficult to find.
There's your login.
Oh, good.
Yes.
Great. So, I actually have already created a user on here, so it doesn't have that. I think the Debian login name is maybe Pi, but the Arch one is root, but I've already created a user on here. And no, it doesn't like me. Fat fingers. Yeah. See, the problem is you get used to the Mac keyboard where the keys are only this thin, so you don't have to push them down very far. And then you get on this thing, and you have to actually press the keys all the way. There we go. Yes. If I stomp on them, it works.
So what shell does it drop into? Is that BusyBox?
No, this is actually a full system.
On both Ubuntu and
Okay, so anyway, I actually have compiled Luon here. I was playing with that a little bit. I think I've got Node. Node.js comes with the Pac-Man system that Arch has. Has anybody used Arch? Did I already ask that? No? No Arch users? Okay, it's a little bit different. It doesn't use apt-get, it uses Pac-Man. And it's a little bit more hands-on. You have to configure things from time to time and fix errors. So, I don't know. If you want to use Debian, I won't hate you for it or anything, but I feel like Arch is a little bit better for this environment. Let's see. Is there perchance any way I can hook into a switch and then like show off a web server off of this thing?
Do we need a cable? Because the jack there is actually.
blue or white?
Brett, can you get this down there? Sure.
Do we know if it works?
Is it what you do?
Das Blinken Lights.
Yeah, it looks like
It's actually right next to the power.
yeah, there's a template.
What is it, one of those links that says PA?
Alright.
I'm not sure that it didn't work.
Okay, so, and this thing doesn't use DH client, I don't think. So I'm just going to reboot it for getting network access because I'm handy like that. So, you good with me? I'll probably get my password wrong. No, I'm gonna write it. Okay, so while that's rebooting, well, I guess I kind of want to leave the display up so it can auto-detect it when it comes back up. But I got up some very interesting schematic and pin layout information that if you want to do some really fun stuff with this, where really fun means attaching wires onto pins, it will give you one of those like 10,000 foot head starts. And got it. Hello. Oh, it seems like it got a little bit faster. Still seems a little slow, but too long.
I'm not sure the phone's on a network that can get anywhere.
Well, we'll find out, and if not, no big deal. But I just wanted to show the concept that you can take 15 lines of Node.js or of Lua Love It and have a web server. So if it doesn't work out, you'll just have to take my word for it. Oh, and they don't use ifconfig, or do they? Did they start providing that? Oh, they did. That's nice. The last version of Arch on Raspberry Pi didn't provide ifconfig because it's deprecated. There's this new command, IP, that everybody's supposed to be using. Arch also ships only with Python 3. You have to manually install Python 2. They're very pragmatic, I guess. Okay, so is this network something that anybody else is on? This 172?
Mine. Yeah, I'm pretty sure it's just a void.
Wi-Fi was 192.168.
Yeah.
12 something.
Let's see. Okay, so unfortunately, it'll be difficult to see this, but I can show this code afterwards, in a gist. Okay. Alright. Oh, I'm missing something different there. Oops. And if you use Debian, then you have to remember to set Etsy hostname and Etsy host to make sure that your hostname is in there and that localhost is in there. Otherwise, everything you do is incredibly slow because for any action you take, even if it's like ls, for some reason it wants to look up the local hostname first and the DNS resolution fails every single time. So it feels like you're going on a machine that's about 1 megahertz. Even though it's not.
Aren't you supposed to be selling us on Arch?
That was Debian. No, that was Debian.
Oh, I see.
No, Arch was, you had no way to get into the system until you searched the forums because by default, well, it's not very clear that this is a serial port. So on all the ARM devices, they have serial ports and that's kind of how you debug them. You log in through serial. Mm-hmm. So it's the same idea as SSH except you use screen or minicom. And then you get it that way. But in the quick start guide, it doesn't tell you that that's a serial port. It tells you to use the HDMI or the component video. And so in the previous version of Arch that released, you boot up the system and there's blank screen and you're like, well, I don't know what to do. Anyway. Shortcut this. Okay, so let's see if this works for me like I hope it does. Alrighty, so now if anybody's on the same network, let me bring back that IP address.
I don't think anyone's on that network.
Oh, well, sadness. Then I will just have to prove it by way of an example this way with curl. If you can actually read what's going on the screen, I'm just going to get localhost. And I did something wrong because it's not working correctly. backgrounded it instead of, I just suspended it on backgrounded. Okay, there we go. Ta-da! So, 15-line web server on an ARM device. You can kind of think of the possibilities. It's what you can fit in your pocket and carry with you and do cool things on. So on that note, I want to show off the serial interface as well, because that is sometimes how you have to get into this when you bork your video settings or whatever. You don't boot into single user mode and tell it to go back to the last good kernel. You connect the serial cable.
So basically the TDI, this thing you use for your Arduino, that cord or that cable, is that basically what you use for your Arduino?
No, I don't think so. I think the Arduino is a little bit different. They do use a COM port, so maybe. Like, if I had an Arduino here, which I do, actually. It's right here. This is a teensy. It does come with a USB cable. It does interface over serial, but you don't get your Linux operating system. The serial interface goes through the Arduino IDE, and then it's just to like program the device.
Right, but it's the same cable, right? TDI?
Yeah, so FTDI, Texas Instruments, and Prolific are the three main.
But this is the same cable, you would use that?
Yeah. Yeah. Okay, so let me bring this up now. And let me get this out again. So I want to connect to this guy over the serial cable, and in order to figure that out, you kind of have to traverse a table that looks like this. And then see these diagrams where it tells you where certain things are. This one I think is all of the input outputs that are supported by the CPU that's on the board, and then they enumerate which ones are actually connected on the die to the PCB. So what things you can access. And this link actually took quite a bit of searching to figure out, and it turned out not to be the right one. This one is actually easier to find, and it turns out to be the right one, but somehow I didn't know it was the right one. It was actually Josh was helping me out with this. Did most of the work on figuring out how we could connect to it. But here it enumerates that the serial connection. Let me see. Oh, that's a lot nicer. So the serial connection is this TXD and RXD, and there's a couple different types of serial. One of them is called, what's it called? TTL, is that this? Something?
Yeah, who does it?
TTL.
Transistor logic.
Transistor logic. Okay, and it's like a lower 3.3 volts as opposed to the normal, like 12 volts. So they do between 5 and 3.3 and 5. So the way that this guy works is this pinout right here is this header on the board that I'm connected to. And so I've got a little adapter that goes from the, I got this on eBay. You can get ones that come in the pretty case that you're used to. In fact, I think I have one of these on the table here as well. But this little adapter goes from the real serial type connection to the lesser serial connection known as TTL. And so the power is actually powering the chip on this device that does the conversion from old school serial to Cool Kid on the Block serial. And then, so there's the power and the ground, and then the TX and the RX. And the cool thing about the TX and RX is you can actually unplug the cable and then be typing from one side to the other. And it's perfectly happy to send, but then it, of course, can't receive, which is kind of a neat thing. So once the cables are connected properly, and you might sometimes want to use a voltmeter to verify that, then you can, nope, that's the wrong keyboard. You want to refresh my memory on this?
1 to 500.
Okay.
Oh, and it's
Does it not show up? Does it see you? Or maybe I need to ls because maybe it doesn't like the auto completion for that, because it's like, I don't believe the screen should do that. And or if all else fails, is it plugged in?
On the other system I'm using is TTY USB 0.
That was under Linux, right? Yeah, so on Linux, I think it generally shows up as TTY USB 0. On Mac, sometimes it shows up as something weird right now.
S0?
I think it's TTY USB with capital USB. Let me see if we got that other connector here. Maybe I don't have the driver for Mac.
Is it TTY ACM?
It always changes.
This is all based on your cable being it's a USB to serial adapter, basically.
Yeah, so I have a USB to serial adapter, and so for some of the boards, the adapter is built onto the board. It's normally an FTDI chip, and for Mac, you need a driver for that. For Linux, it's built in. For Windows, I think you need to download the driver as well. And then the other really popular one is Prolific, and the Prolifics are the ones that are in the cheap adapters, and the FTDIs are the ones that are generally on the boards, from what I've noticed. And if I have the other adapter here, then I'll just connect it real quick. Is this it? Ah, here we go. Let's see. Are the colors the same?
Good question.
I want this one. At least it should show up in the device list this way. So we've got the green and the white. Do you happen to remember which one was transmit and receive? Did we keep purple the same? Because if we kept purple the same, then...
I don't know.
Okay, well, I got a 50-50 chance. It's not going to blow anything. Not a 50-50 chance it won't blow, but a 50-50 chance and it won't blow anything. So, okay.
Voltages and amperages are very low here.
The what?
The voltages and amperages involved are very low.
Oh, it's the 0, 1, 2, 3, 3, and 4? They're right next to each other.
Yeah, it's the power.
Power, space, ground,
Yeah.
and then
And
TXO.
the top is the transfer.
Yeah, so like it says here on the diagram, power, nothing, or reserved, ground, transmit, receive. So maybe I get lucky, maybe this works. TTY dot. And there we go. There's my USB serial. So screen, and then give the device, and then 1, 15, 200.
Other 112, 500.
112.
It would be 115.
Oh, okay.
All right.
Users.
Okay, so, haha, look at that. And here I am, logged in over a serial connection. So with most of these devices, that's how you'll get started when you first boot up, and then you have to configure your video or whatever, depending on the operating system you're going with and what board it is. But this guy here, works the same way. I've got this nice fat adapter plugged out the side here.
Yeah, look at that.
And then the last trick that I wanted to show as a live demonstration, very dangerous, was to see if we could get a GPIO.
It's,
Were you going to test that?
You have LEDs here?
Yeah, red LED. Where'd it go? I brought all the things.
Except the HDMI.
Yep, except the HDMI adapter. Oh. Well, I know there's an LED right here in this, but I did have, right here. I've got the big LEDs. These are easy to work with. And then I've got a resistor so that we don't blow the LED. So does anybody know what GPIO, I2C, that kind of terminology is? Yeah? One person? That's good. 2, 3. Oh, we're climbing in numbers.
Was it general IO?
Yeah,
General
it's general purpose I/O, and with Linux and Arduino, they're really, really easy to use.
It's the ASDC, so that's for your I2C.
Yeah, I2C, I2C, yeah. And then SPI as well. This
Oh, yeah, for your...
Mozy, Miso, S-Clock. So the way these things work is there's a config file. Either with the bootloader, you can tell the bootloader to configure these pins to be input pins or output pins or GPIOs or secondary functions. Because the CPU on board has the functionality to say, like, I want these 4 pins to act as a serial port, or I want these 4 pins to act as an SD card reader, or I want these 3 pins to act as a SPI bus, which is like poor man's USB, except really, really poor man's USB. And so some of these are already configured. We just like ls.
So actually copy some of the commands into your directory.
Okay. In GPIO, this next file?
No, that's cool. So we do the.
Oh, so I'm
The GPIO pin is to
0.
Yeah, so assuming you're using 0, but I'm using 4 here.
Oh, you're using 4, so we should change it to 4?
Yeah.
Okay. So
I don't know if it'll work, but
GPIO 4 is right here. Okay, that also has a secondary function. Should we try GPIO 17? Because
Try that one, yeah.
let's try 17 because that one doesn't look like it has a secondary function, so maybe more likely to work. So what I'm doing here is I'm telling the kernel to tell the CPU that a wire on this board should behave differently than the way that it's been behaving. So I'm saying take the wire that is internally known. Oh, right, because I got to do this thing. Like that, it'll work. Okay. And then let me cat that file again. So we tell it which one we want. We want wire 17 to act as a GPIO. And then we tell it the direction. We want it to be an output pin rather than an input pin. Why does it ask me again for that? Maybe we didn't get so lucky. I'll just try it.
it's GPIO, so skip it.
Okay, we did get 17 though, so it did export. Great. Let me just root real quick. Okay. So echo out. And so now we should be ready, right?
Yeah.
So is
bring up the pins again.
okay. So we should connect it to ground and 17. So that should be 3.3 volts and ground. And then where'd that resistor go? Let me see where my bag is real quick. I think this one is the add resistance.
Does that resistor have color bands? Does that resistor have the color bands?
It does have color bands. I'm not exactly sure what they mean, but I had my hardware friend help me pick it out beforehand.
What colors do you have?
This is brown, green, brown.
No, red was 1, brown is 2,
And then brown, black, red, yeah.
black.
Black, brown.
No, it is black, brown, red, and then through the rainbow.
Well, even if it's wrong, it'll at least work for a second.
If there was, I only have the internet to look it up.
Oh, yes.
Green.
Well, this is, I brought 2, and this one's the more resistance one. So, okay, so this should be our power. The red one?
Yeah.
Okay. And then our ground is the black one?
Yep.
So, let's see. Das blinken lights. And let me tell it to set the value to 1. So setting the value to 1 here is what tells it that it should be 5 volts or 3.3 volts instead of 0 volts. Did it turn on?
Yeah.
Alright, that looks like it's actually a little too high power. Let me try the other one.
It's pretty dim, actually.
Well, no, I meant the resistor was too resistive here. Because these were the 2 guesses I was given as to which ones would be right.
Probably
This one is
Black,
decent
red.
simpler. Red, brown. Yeah.
That's gonna irritate me, I'll look it up.
Okay, still quite a bit down. Oh, maybe it's because this is a bigger LED and it's only 3.3
1
volts.
110 ohms.
You can see it. Anyway, so you can see it here. You want to hold that for a second? And I just want to point out that 90% of the brains behind this demonstration today is Josh here. So I don't.
Ask him questions on you.
Oh, so it turns off and turns on. So there's small demonstration of hacking if you want to turn a light on. I mean, this is what your Android phone does, right? Your Android phone, when you get a Twitter feed and the little, well, I guess iPhone doesn't have the light, but all the Android phones have the light on the front where they go like red or green to let you know if it's out of battery or if it's a Twitter feed or whatever. Because basically what they're doing is they've got some Java program that's doing the equivalent of what we've done here on the shell of catting out 1 and 0 every half second to let you know that your battery's dead. And if it wants to turn it red, it cats it out to GPIO 18, and when it wants to turn it blue, it cats it out to GPIO 17, or however that works. But so was there anything else that was important? Oh, there was using the serial port.
Yeah. There were.
You've got a blog post on that, don't you?
Yeah.
Okay. You want to direct me to that?
Joshua C. Elliott at
Oh.
So that's the instructions to, because the kernel is going to take over the UART or whatever the serial ports on that, and so in order to do something else instead of just logging in over that, you're going to have to disable that. So there were 2 things that I had to change, and yeah, so the first one was to tell Getty to not use that.
And this was in Debian.
Yeah.
So I don't know if the exact same thing applies, but this will give you a head start if you want to do that kind of thing.
And then the second was to remove that from the boot command line. And so once you do those 2, you won't be able to log in over the serial anymore, but then you can use it for your own type of thing. So with whatever you want to use, you can get a little chat thing going over it,
Or if you want to hook up a GPS to it, GPS modules often communicate over serial. And then if you get really fancy, you can go, and I'll give the links to these, but you can go through, this is the CPU PDF, so it's like 500 pages of everything you never wanted to know about anything that can possibly be done with the CPU. And then again, this table right here shows every single pin that comes out of the CPU and whether or not it comes out to the board, to a place where you can access it.
Is that like coming out on those little ribbon header things? Is that
Yeah, so the ribbon headers, I believe they're all listed there. These pins here, I think this might be JTAG. I'm not positive on that.
Actually, they're a feature for putting in a camera and your own little screen.
Yeah.
That's what those 2 connectors are for.
Yeah, so if you want to do an LCD screen and a webcam, you can put that on there. I think you can force it to be other stuff if you want to.
I'm sure you can.
And that's where these tables come into play. If you want to say, hey, pin that's acting like nothing, start acting like a GPIO, you can just hack these things and bit bang. And then let's see, there's one more right here. Yeah, and then here's a schematic here if you want to get your electrical engineer hat on. So with this kind of information, you can start working on fun projects on the Pi. So I hope that was enjoyable and you learned something.
Did you say on this table you found some stuff that was incorrect? Or
so you have to look at the forums a little bit because this stuff gets updated, but the documentation is not exactly in sync with the printed board.
That is because it's being reverse engineered as we go. It's not like we have the full docs of the hardware. So they're kind of discovering this, sort of.
Yeah, so, and also they want to use certain pins, like there's pins that are marked as nothing right now. Where did that go? Where was it at? I know it's on here. There it is already. Oh, it's this one, yeah. I just gotta scroll. So there's these pins that are marked as unused, and they want to do something with them, and some of them might currently do something, but if they do something, you can't expect that behavior in the future. So the revision of the Pi right now, the stuff that's online is fairly accurate, but the next revision of the Pi will be slightly different. You shouldn't break anything, but there should be some things that have been added, and perhaps default configurations will change. So by default, that GPIO 17 didn't exist, and I had to tell the kernel, tell this wire to act as a GPIO. In the future, they might have the bootloader set that up automatically, or stuff like that. Any other questions?
How big of an SD card did you need?
I think you can use as small as a couple hundred megabytes. So let me go back to my downloads folder real quick. So this one is 1.8 gigabytes, and my guess is the reason for it being that big is that's what they're defining the partition as. And you can use your your FDisk and E2FS resize to have it take, if you have a 16 gigabyte card, you might want to expand your partition table and expand the file system to fit that partition table. And likewise, you can shrink it down. You don't need 2 gigabytes. You can reasonably operate with as little as probably 60 megabytes if you get a small trimmed down distribution. The compressed Arch file size is 200 megabytes, and that's kind of big. You could definitely get smaller than that. The Debian one I think is 400. It kind of comes with the kitchen sink. Arch is really slim, so things that you might expect to be there aren't necessarily there.
Yeah, based on this one, or?
I don't, but I have it on this card, so I can put in this card, and then in theory we can power this up and see X run on it. Unfortunately, Chromium and Firefox have not been made easy to get. So if you want a browser that can do YouTube, they've done it. They have a demo on their website where they've done it, but those instructions on how they compiled it for this processor are not super easy to find. But let's see, if I switch this out, I think we'll see it boot into X on the Debian one.
Is there something like XBMC or?
Yeah, there's an XBMC distribution as well. I don't know where you find that, but they tout it on their website. They're like when they originally made the first batch of a half dozen boards, they made videos of the things that they did, and they have something like an XBMC.
How does it do with high def video? Can it do 1080p?
Yes,
It can.
Or
1080
1080i?
Yeah.
So it won't do 24 frame?
Oh, well, 30's under, 24's under 30, but how well it'll encode that to the normal 29.97, who knows?
So there's
That's what I
one
wanna see.
One thing I should have mentioned, but I didn't, and I'll send this out on the list so you have a link to it, but there is,
People are doing 720p all the time with it on the videos.
oh, maybe I'll just go in here and look back up. I'm going to try rebooting this, maybe it didn't catch it in time maybe it didn't catch it in time. So, and rebooting is as simple as unplugging the power and plugging it back in. Just make sure you sync twice. Thing about SD cards that you need to know, when you do a sync, that tells your file system and the kernel to flush their buffers. The disk, even a small disk like this, also has buffers on it that could, probably for this you're looking in the range of maybe 4 megabytes. So however long your card takes to write 4 megabytes, you should wait that long before taking out the card. Otherwise you will ruin your card even when your operating system says it's safe, because the internal cache on the chipset needs to flush. Okay, so this one looks like did not come up with a nice desktop environment, unfortunately.
You have to set a manual to do it if you want it automatically.
Let's see. I don't remember. I think last time I just did Start X. Maybe.
Okay.
Oh, is this one just root group or Pi group? I don't know which one is
Pi.
This is Debian.
I've got it.
Let's look it up real quick.
Is this the one we were using earlier, or is this one that you installed in a fresh copy?
This is a fresh copy of Debian. I overwrote the other one. Username is Pi, password is Raspberry. And it's a bit slow, as you might expect, to use the desktop operating system, but it's usable. I mean, I've basically got a Dell GX280 that's like a gigahertz processor, and this probably outperforms that. And Pocket Mouse, anybody have one? Let's see. Thanks. And I might actually have to reboot it. I don't know if the plug and play will work as well as hoped or not.
There's a mouse pad too.
Oh yeah, it worked.
All right, cool. So let's see. Does the Debian one come with something fun? How do we get on the internet with this sucker? Yeah. So no real browser. You basically get the experience of maybe Firefox 1 or something, if it chooses to open. Yeah, actually. So. Oh, there we go.
Yeah, but you're on the Zoic line, so if I'm not in there.
So let's see if I can go to Google.
Oh, that's a file.
Nah. Oh well. Oh, so the one last thing I was going to mention. So this has a firmware that's I think on the CPU die or in that package set that tells it how much memory it's supposed to use for the GPU versus the CPU. And I think the site, I'd have to switch this, I won't right now, but I think it's called Raspberry Pi Update. It's available on GitHub. It should work on Debian as well as Arch and the other distributions because it's not as much an operating system thing as it is interfacing with the chipset and telling it to switch. I may be wrong on that. But I ran that, and then it changed the amount of memory that when my system boots, it now has 192 megabytes of memory dedicated to Linux, and then it's got another, what is it, 32, 64? 64? Yeah, 64 of the of the memory is dedicated towards the GPU. And so that gets into the DSP arena. Like when you want to use your MP3 decoder, GNOME, what's the one in GNOME called? That actually does the decoding, the GST? GStreamer, yeah. So like GStreamer for the Pi, if it's done right, will be specially compiled to access the DSP, and then it will use like the hidden 64 megabytes of memory possibly. I don't know if that is just the, I might be mistaken about this on the Pi. I don't know if the GPU doubles as a DSP or not, but with some of the embedded systems, it works out that way where you split your RAM amongst the different chips, the GPU, the DSP, and the ARM, and then when you go to do your decoding of video and audio, it exports that off with a specially compiled version of GStreamer or other tools like that, so that they know not to try to use the CPU, but to use the GPU or the DSP instead, so that they can get the performance and the power saving. Because one of the miracles of ARM is your business logic, if, then, else, go to, that is done on the ARM. Your algorithmic logic, your MP3, video, etc., that's either done on your GPU or your DSP. So you've got the right tool for the job, and hence it's so low power and low heat. Anything else?
So Midori is the only browser that you've tried?
You can get other ones.
Have you tried UZBL or
Which one?
UZBL?
ZBL?
Yeah.
No, I haven't tried that. I think I had Dilio, was the other one I tried. And you can get Firefox for ARM and Chromium for ARM. They have been built, but they aren't easily, they're not distributed through the main package managers. It's like one-offs, people have written a blog about it, then the code gets updated, then it doesn't build anymore. So, some of the other...
I'd imagine with that little amount of memory that you wouldn't want to run Firefox or Chrome.
Maybe not. But
It'd be a little slow.
I'm pretty sure, I know that on the Panda board, because another thing is they're trying to target the newer processors. So the Panda board is an OMAP 4, and that's a pretty new ARM processor. It came out maybe a year and a half ago, anybody know? As opposed to this Broadcom chip, which is maybe 5 years old or older. I don't know how long that's been around. But a lot of these vendors, they want to target the newer processors because they're easier to work with. Basically, your Nintendo DS, or maybe not even the DS prior to that, is using a chip like this, where it just doesn't have a lot of capabilities, and this thing is more like what your PlayStation Portable is going to be running on. So it's a big difference, and for them to try to get Firefox working on the Pi, of course there's a big push for it because there's a community behind it, but it's old hardware and it's difficult. It doesnn't have the instruction sets and the optimizations. Anything else? That's all I've got.
Before the meeting, somebody was talking about doing like UAVs or something. What's the coolest project that anyone's heard about somebody doing with the Pi?
I would check on their wiki for that.
It's a really cool voice control robot arm that somebody built. I think that was the coolest thing I saw.
That was the thing on their opening page.
What was that?
That was on their homepage.
Yeah.
Too.
Yeah.
I've seen a pretty interesting project listing with Arduino. I'll open that up. Anything that you can do with that, you could certainly do with